Hello, my name is Eylül İdil Yıldız and I'm a second-year computer science student at Bilkent University. I'm in Physics 102, Section 11, and today I will be conducting an experiment for my Physics 102 course project. In this experiment, we will be investigating the relationship between the electromotive force induced in the wire when a magnet is passed through the copper coil and the number of turns and the radius of the copper wire. For an object in a magnetic field, the amount of magnetic field lines passing through a surface is called magnetic flux. In a system where the magnetic force is uniform, the magnetic flux is equal to the product of the surface area and the component of magnetic field perpendicular to the surface. Moving the magnet inside this loop will cause this magnetic flux to change, creating a current in the wire. And, according to Faraday's law, the EMF induced is the negative change in the magnetic flux per unit time. In other words, increasing or decreasing the amount of magnetic field lines passing through the surface area causes an EMF to be induced that is opposite to the change. And if this copper wire is wrapped, say n times, the induced EMF in this coil is also multiplied by n. In order to conduct this experiment, we will need some copper coils of different sizes and different number of turns, a magnet, cable sets, a multimeter, a ruler, and some electrical tapes. Here are the coils I've prepared, and the coils I tested had the following qualities respectively. Radius 2.5, number of turns 10. Radius 2.5 centimeters, number of turns 15. Radius 2.5 centimeters, number of turns 25. Radius 2 centimeters, number of turns 15. And radius of 3 centimeters and number of turns 15. Here I recorded the results of experiment 1 to table 1. According to these results, I plotted the electromotive force and number of turns graph and observed that it was increasing linearly in accordance with the theory. Then I recorded the results of experiment 2 into table 2. Looking at these results, I plotted the graph of the radius of the coil and EMF relationship and observed that EMF was actually a quadratic function of the radius of the coil, meaning that the EMF increased directly proportional to the square of the radius. And lastly, I've plotted the area EMF graph and observed that it was increasing linearly as expected. Thank you for listening.